Well, thanks a lot. And a special thank to Brian, because he introduced everything you need to know to follow my presentation. This morning we heard about, Fergal was introduced, the river basin management plans, and this presentation is about the first works that have been done to the Lower Shannon hydroelectric scheme. So a bit of background to the whole scheme. The Shannon Act basically paved the way for the development and the construction of the Shannon scheme, which basically is a diversion scheme, consists of Parteen Weir and the Ardna Crusher station. Ardna Crusher was built in a record-breaking time of 4 years, and the first unit began operating in 1929. However, with regards to fish passage, it was believed at the time that adult returning salmon would actually move into the river, into the old river, with their homing instinct and follow the old river upstream. But that was wrong. What happened was that they actually followed the tailrace towards the hydroelectric station where there wasn't a fish pass in place. There was a fish pass in place, or still is, at Parteen Weir. I'll show you in a minute. But numbers of salmon really crashed after operation. Within a couple of years, numbers went down to probably about 10% of the former population. And that's why 30 years into the operation, a fish lift was built, a fish lock. It's actually still the highest fish lock in the world, and that was retrofitted in 1959. But nevertheless, we've got 2 fish passes at those barriers. We're still down in very low numbers, around 4%. Figures vary from year to year, but we're down to about 4% of a self-sustaining salmon stock in the Shannon. So one of the key objectives in the last river basin management were for the department to actually set up and lead a steering group. And the steering group brought together all the major stakeholders on the Shannon River. And the steering group was then mandated to investigate or consider 3 things. First, to investigate the impacts of the barrier on the Lower Shannon more generally. Then assess the feasibility of implementing measures to improve fish passage and determine the optimum solution. What you see here on the right-hand side is the area of consideration. I want to point out a few aspects. I'll start at the top right. Basically, this is Parteen Basin that was basically impounded. It's the impounded reach of the Shannon, about 8 kilometers long. When Parteen Weir was built, it pounds back to Killaloe. And then it splits into about 13-kilometer long head race with a hydropower plant down there, if I'm pointing to the right spot. And then there's about 2.5 kilometers of tail race. The old River Shannon is about 17 kilometers in length, and they meet at the confluence, and we'll get to that point in a minute because it plays a special role. We investigated 3 things. We looked into upstream fish passage, fish protection, downstream movement, and the hydrological impact of the scheme. And I can tell you the Shannon scheme is highly complex. All those things are things that we need to look into to better understand the system and to actually work out optimum solutions. So we looked into the sensitivity of the site. We're in an SAC site. We needed to understand the operation of the scheme, ESB's obligations, dam security, shipping, navigation, flood protection. We investigated international best practice. And all this was done at the start of the project to get a common understanding within the steering group. So just a summary of our initial assessment. So as I pointed out, there are 2 fish passes. Parteen is a traverse type, a pool type fish pass, and the Ardna Crusher fish lock. We found that at the time of when they were designed, they were really I was amazed at the thoughts that went into the design of those facilities. But from a nowadays view, as Brian just explained, they do not pass multiple fish species. And in our view, they can't really be put into best practice again. They need to be removed and replaced. Elverpasses, the ESB has put in a couple of elverpasses both at Ardnacrusha and Parteen in the last couple of years. Those are sort of for young upstream migrating eels, so that is a good news. And we found the old River Shannon, despite the low flow, has a fairly good hydromorphological structure, but nevertheless there's quite a few sort of rock ramp bars that actually potentially could hamper fish passage movement, especially in the long periods of low flow. With regards to downstream fish passage, that is never blocked completely, whereas if you haven't got an upstream fish pass, fish can always find their way downstream, and it's mostly through the turbines. And surveys in the past have actually confirmed that we have an issue. Both salmon, smolt, and eel investigations have confirmed that fish get harmed. There's also what we know from other schemes that there's a reservoir-specific fish loss. We don't know anything about that in the Parteen Basin yet. Ardnacrusha Station hasn't got specific fish protection facilities or downstream fishways, so bypasses that sort of provide a safe route past the hydropower plant. But what the ESB do, they actually exercise what's called a smolt generation protocol. So when the small salmon smolts move downstream, they operate the turbines in a special mode to increase turbine survival. Another thing that's done in Killaloe, there's an old eel weir, and that is used to actually capture downstream migrating silver eels. Not all, because it doesn't span the entire bridge where it sits, but it captures a number of fish, and those are actually then trapped and actually manually transported downstream into the estuary. And the model of the National University Galway sort of thinks the total escapement is around 90%. Turbine mortality of eels is much higher, is about 20% in Ardnacrusha. And then changes to flow dynamics. So Parteen definitely changed the complete hydrology in the lower River Shannon. So it altered the magnitude, the frequency, duration of flows. Obviously, water levels, and the Shannon was impounded by up to 7 meters. And the Shannon, the Ardnacrusha scheme has a hydraulic capacity of 400 cubic meters compared to about 190 cubic meters of mean flow of the Shannon. Actually means that it's got what we call a very high hydropower ratio. So basically what it can do, it can harvest water almost all year round. So only during really low conditions, the turbine stands still and there's no water flowing. So what happens is, because there's only a very low minimum flow in the old River Shannon, basically because of this high hydropower ratio, you get about 11 months per year on average with only the compensation flow of 10 cubics down the old River Shannon, which is a very stagnant, very, very long period of continuous low flow. And obviously, this is not international, or especially not good European practice. So basically, we worked out options for all the different aspects that I just introduced, and I can't present all of them, and I've just picked a few that I wanted to briefly sort of describe, is the ideas for a new fish pass at Parteen Weir, a tailrace barrier concept, and I'll focus on an environmental flow concept that we developed as part of that study. So the fish passage improvements, looking at the upstream passage, we developed two concepts. We called them U1 and U2. U2 is basically the setup as we would have today. The idea is to build two new fish passes, one at the Parteen Weir and one at the Ardnacrusha Station. And then fish would be, as today, able to move upstream either through the old River Shannon or the head and tailrace. However, any type of improved flow regime in the old River Shannon would hopefully trigger more fish to move into the old River Shannon. Building a new fish pass at a 30-meter high dam is a very difficult exercise, and I can tell you that wasn't the favorite way to go. So therefore, we suggested another concept which was already pursued a couple of years ago, is looking into the feasibility of a tailrace barrier. So basically blocking fish of moving into the tailrace toward the hydropower scheme and trying to convince them to move up in the Old River Shannon. This would certainly involve an improved environmental flow regime, and then that would hopefully trigger fish to move up in the Old River Shannon and pass through the fish pass at Parteen. So as you can see, the fish pass at Parteen is basically a common measure of both concepts. It is really an easy thing to progress further. We know what to do with Upstream and how to design upstream fish passes. The next things that need to be done are just sort of a classic engineering approach. Obviously, planning, cost, and environmental assessments need to be done. We looked into different designs that would be suitable for the specific conditions at Parteen Weir, and we determined the so-called vertical slot fish pass to be the optimum solution, and we suggested that to be progressed. So following the idea of blocking the fish of moving into the tailrace, we developed concepts for a tailrace barrier. We looked into 4 options. One's a screen barrier, one's a barrier dam, an electric barrier, and a new type of hybrid electric barriers. Those are sort of things that haven't been built so often, so what we recommended is that due to several reasons and things that would need to be investigated, like health and safety, fisheries effectiveness, and so on, we suggested a real good feasibility to be studied, feasibility study to be carried out next. And I'll be drilling into the specific details of the location in the next slide. So the idea was to build the tailrace barrier right at the end of the tailrace, where it meets with the Old River Shannon. As you can see in this slide, the system is quite flexible and variable as well. So the Old River Shannon actually receives inflows from tributaries such as the Marq and the Kilmastulla, and those are variable. So you get about, depending on which season you're in, flows of sort of 14 to 25 cubic meters of flow in the Old River Shannon. And on the other side, the tailrace, the flows can be anything between 0 and 400 cumecs. So as you can see, that was the reason why the fish are actually moving upstream towards the Shannon, the Ardnacrush hydropower station. These flow velocity measurements that OPW conducted for us actually show the situation that in the actual confluence area, the Old River Shannon, the flows are really, really slow. And this is one of the big issues. And we conducted a 2D model to actually highlight those issues. And I need my colleague in the back to actually start that video. So it actually shows that the flow velocities in the area where we want fish to move into with a tailrace barrier here, because we want them to carry on their movement fairly quickly without losing any time. We used what we call an ether hydraulic color scale to actually show that the flows are very, very low. Fish have got what we call certain rheotactic flow velocities. Those are the velocities they need at minimum to actually sense the flow and the way they need to go. And those are, for salmonids, are in the area of about 0.3 meters per second. So basically, what we can see from here, we definitely need more flow going through the Old River Shannon to convince fish to move into the system. So we developed an environmental flow concept, and e-flow concepts are very much about setting objectives, and I was targeted to deliver a fish pass-oriented concept, so we came up with certain objectives. First and foremost were obviously to improve the fish migration into the Old River Shannon, but also obviously not to deteriorate the conditions in the Old River Shannon. We wanted this, the concept to reflect a better hydrology, a more natural hydrology, and take account of the system itself, especially the inflows and the retention of Loch Derg upstream. On the other hand, we wanted the e-flow concept to be cognizant of sort of balancing the energy loss and generation loss of the Ardna Crusher scheme when more flow is spilled down the Old River Shannon. And we wanted to consider the interests of other users. You might have heard of the proposed abstraction regime of Irish water. And then there's many, many other things that I don't want to go into detail. There's quite a few international recommendations or European recommendations for impoundments, so e-flow concepts, and one I've found very appropriate for the Shannon scheme is what's called a building block methodology. So the idea is you have a minimum base flow that is basically spilled during the dry flow situations or low flow situations, drought seasons, but you normally would have a raised base flow, a continuous raised flow, that basically is spilled in normal flow conditions. And then, in order to trigger the movements of fish, for example, or to facilitate downstream migration of eels, for example, you would be spilling so-called freshets, so small and temporary spills downstream. Those could be predetermined either by date or volume, seasonally, depending on migration times of fish or flow dependent. And then when the station capacity is exceeded, that's when the large volumes are spilled into the depleted reach. So we used our 2D hydraulic model to actually determine the amount of flow that's required to create these so-called radioactive velocities. So velocities that fish can actually sense and move into the Old River Shannon. And the values that we worked out for different scenarios are in the order of about 45 cubic meters for flow velocities if we target salmonid species. So that's definitely much more than is flowing in the Old River Shannon today and is season dependent on the tributary inflows into the Old River Shannon. So those were the figures that we used to determine or to work with the freshets. And the concept that we ended up with is basically we suggested the minimum flow, to keep the minimum flow as it is, so the base flow, that's what we proposed to be in the order of 10 cubic meters per second. Once the inflow to Loch Derg is about a Q97, then we would increase this base flow, so raise the base flow to a figure which is a normal sort of common figure if you look at European best practice criteria of 17 cubic meters per second. And then the freshets, those are the ones that we actually modeled or that are suggested from other guidelines. Those would be in the order of extra spills at Parteen Weir of around up to about 30-35 cubics. Plus the tributary inflow would create those flow figures that you just saw. Seasonally dependent, eels move downstream sort of October to December. That's when we proposed higher flow figures to be spilled during the night times. That's when eels migrate downstream. And then, as is the situation today, spills would be spilled down the Old River Shannon when the capacity is exceeded. So in all, we worked those out and trialed those with average hydrological years. You can see the sort of an average year, that's 1992. The concept works quite nice, and what it actually shows is that the base flow period is really reduced from 11 months to almost 2 months per year. So there's much longer periods where there's higher flow in the river. And then you've got certain periods where you're spilling the freshets. One consequence is that this creates a significant generation and therefore revenue loss to the hydropower owner. Just to give you a couple of figures, so a normal higher spill would create losses of about 1.8 million in revenue per year for the ESB. With an e-flow concept like this, you could lower it to about 650,000 euro energy loss with a very sort of focused environmental flow concept. So what's next? Our roadmap of actions that we sort of worked out for the next management period, that found its way into the draft river-based management plan that was presented this morning, and the department is now finalizing the sort of the actions that need to be taken to progress this roadmap of different actions and measures forward. And with this, I want to thank you very much, and hopefully we'll be seeing fish moving upstream like in this picture soon at the Shannon.